Okay, well, welcome back, and we're going to be talking about comparative, or sorry, not comparative, but box plots today. And we're talking about 1.3, and when we have the box plots, and also how to find the center, IQR, and really talking about outliers today. A lot of stuff about outliers. That one's one of the key things. And so, in this second section of 1.3b, let's get started here. So first off, IQR. IQR stands for interquartile range. Interquartile range. You can look that up online, and that's what you'll see. Now, how do you find interquartile range? Well, first off, you have quartiles. That means there's 4 different spots. And maybe we can start over here with the box plot. Is we have what's known as the median, we have quartile 1, we have the min, quartile 1, median, also known as M, quartile 3, and we have our max. With these 1, 2, 3, 4, 5, this is known as the 5-point summary or 5-number summary. Okay. With this IQR is really this box in between, and it's the length of this box. So how we figure this out is we take Q3 minus Q1, and that will give us what our interquartile range is, all right? Based on the length of that box, all right? The length of the box. And so now the next thing is we use this interquartile range, and the 1.5 rule, which that's mathematicians just decided on a long time ago, which seemed to be a reasonable way of trying to figure out what outliers are, all right? Identify outliers. And so this is what we do. In order to identify outliers, we can find a lower outlier is if you notice that you have 1.5 of times whatever the IQR is. So whatever that is, you multiply that by 1.5, and then you subtract that, all right? You take that value and subtract that from our Q1, okay? And you take that and you subtract it from Q1. So anything that is less than this, so you basically take Q1 and whatever that 1.5 times IQR is, that length, if that is less than whatever you have, that's what we refer to as an outlier. So Q1 minus 1.5 times IQR, that's what's going to give you your value that is going to be where your outlier range is. Same way, if you take your Q3, and so we want to figure out if it's going to be greater than, well, if we know if we have an outlier, that means if we take our 1.5 times IQR and we add that to Q3 because we figure out what the values are. So anything greater than this value is going to be the outlier for that. Another way of doing this is if you have standard deviation. So that SD means standard deviation rule. And it's basically 2 or more standard deviations. So essentially, if you take your mean and you subtract 2 standard deviations from that mean, anything lower than that value will give you your lower outlier. That's a 2 standard deviation rule. In the same way, if we have our, mean and we add 2 standard deviations, okay, that will give us our higher outlier. Okay, so 2 different ways of finding outliers, one involving standard deviation, the other one involving IQR. Okay, so over here, talking about this box plot a little bit more, and IQRs and whatnot, is that each one of these quartiles represents 25% of the data in each section. Okay, the IQR is the middle of the 50%, is basically the middle 50%, and that is located inside the box. All right, that is what the box plot that represents 50% of the data. 50% of the data. It's not the first 50 or the bottom 50. It is just 50% of the data is inside the box. Okay. Other things when we're comparing distribution is when you're talking about box plots. Now, normally on the AP test, they do not consider box plots able to determine the shape specifically, but we actually can. So if you notice, like for example, a box plot like this, okay, and you have this huge line right here, this essentially means you are skewed. Okay. In this case, it would be skewed to the, because you probably had some outliers or very large values over here, it'd be skewed to the left. Okay, this would be skewed to the left. You can also hit it skew to the right if you notice that you have same kind of thing, and you notice you have a huge point over here. All right, this would be skewed to the right. And you can notice that. And then if you have like a box plot like this, and it's kind of in the middle, and you notice over here, and you got a little bit in the middle. All right, this is more symmetric. That'll be a more symmetric distribution if you look at that. Outliers, we can use the 1.5 IQR rule. All right, when we're talking about that, we can also use 2 standard deviation rule. Okay, that's how we can find outliers. The center, if it is skewed, we're going to use the median. If it's symmetric, I mean, we can use median as well, but we can also use our mean, okay, if it's symmetric data. But we could use both because it's going to be relatively the same. Spread, if it is skewed, we're using IQR. Okay, the IQR is what we determine for spread. If it's symmetric, we could use IQR, but a better thing would be standard deviation if it's symmetric, as we talked about before. Always make sure whenever you talk about distributions, you always include context. Also, if you're comparing distributions, make sure you use comparative language, such as greater than, less than, all right, similar, okay, and so on and so forth that you can use. So use comparative language into that. Okay, and so that is what we know about 1.3. Here are the notes for that. This is really, really important stuff. On the AP test, you will always have something talking about outliers. So it is important that you have that. And you know stuff about box plots. That is one of the key things that comes up. And this will help us identify different things when we start talking about percentiles and other things that way. All right, so really important section. Hopefully you got this down. And we'll talk about some more examples using this in the next videos.